Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we're going to look at an example problem for absorption. As a reminder, these are our formulas. This is a selection of the possible formulas, but for calculating the height and number of theoretical units based on film coefficients or overall gas or liquid mass transfer coefficients. And we have the integral form, which is exact, and then we also have an approximation based on delta y or delta x log mean that can be used whenever our operating line and equilibrium curve are both approximatable as a straight line. So in this example problem, what we have is a gas stream containing 3% A passing through a packed column that is going to remove 99% of A by absorption with water, so just pure water. The absorber is going to operate at 25 degrees C in 1 atmosphere, which determines our equilibrium data for us. The gas flow rate is 20 moles per hour per square foot, so that's our V over S. And the liquid flow rate is 100 moles per hour per square foot, which is our L over S. And we want to find the total height of packing. And we want to do it two ways, based on the overall gas mass transfer coefficient and the overall liquid transfer coefficient. Our equilibrium can be described as y star equals 3.1x, and kxa and kya are given here. Now I've drawn a little sketch off to the side here, and you should probably get in the habit of always doing that. This is really a challenge to do if you're not drawing a picture and making a determination up front whether this is an absorber or a stripper. And in this case, what we are doing is we are taking a contaminant out of a gas and moving it into the liquid. So from the point of view of the liquid, it is absorbing material in this device. So therefore, this is an absorber. Never trust the wording of the question. Since they specified first to solve this using the overall y formulas, I have summarized those up at the top. And the first thing we need to do is figure out our material balance. So how much A is entering, how much A is leaving in each stream? Let's do those calculations. So the A that comes in was described as being 3% of my V over S is 20, so 0.6 moles of A per hour per square foot. 99% of it is removed, so therefore 1% remains, so the A leaving with the vapor is 0.006 moles per hour square foot. And the A in the liquid must be the rest of it, so subtract the two and we get 0.594. Now, we know L over S is equal to 100, so therefore I can determine X, and I know equilibrium relationships, so yi is 3.1x, where the gas comes in, we have x is equal to 0, and so therefore I know my y, and at the other end, I have this. So therefore, I know what the y minus y star is at the top and the bottom of the tower. So at the top, it's just 0.0003, and at the bottom, it's 0.01159. I can use that then to estimate my delta y log mean, which turns out to be 0.00309. And therefore, my N for overall gas phase is the delta y from top to bottom over this delta y star log mean, 0.00594 over 0.00309 is 9.61. Now to figure out my H, I need to use a capital KY. So let's calculate that. taking the reciprocal of my lowercase, my film coefficient kya, and the slope from the equilibrium curve over the kxa, add those together, take the reciprocal, I get 8.45 for my answer. And so therefore HOY is equal to V over S over KYA, which is 2.37 feet. And therefore Z is the product of H and N, or 22.7 feet. So now let's next look at this for the liquid phase. Now this time my formulas are going to be for NOx and HOx, and I'm going to need a capital KXA. My material balance remains the same, and so I know what is going in and out at the top and at the bottom. But what I need to know is X star, because my driving force this time is X star minus X. And so in this case, X star can be estimated by taking the Y value divided by 3.1. And at the top of the tower, it's 9.677 times 10 to the 5th. And at the bottom of the tower, X star is 0.009677. I'm going to then use this to estimate delta X log mean. Now remember, delta X log mean is based on the difference between X and X star. And this time it turns out to be 9.96 times 10 to the minus 4th. NOx, therefore, is going to be the difference between my x's at the top and the bottom divided by this delta X log mean. So I get 5.96. So that's a very different number than I had before. But if we look at this, KXA is 1 over 60 plus 1 over, our slope is 3.1, KYA is 15 to the negative 1 power, 26.2. HOX, therefore, is 100 over 26.2, 3.817 feet. ZT, therefore, 5.96 times 3.817 feet is 22.7 feet. So I get the same answer both ways. So this concludes this example. We will come back and look at a different example in our next lesson. Thank you very much for your time.